Hello everyone, welcome. Hello everyone, welcome to the third day of Monsoon seminar series. And today with us, we have another special guest, and we have with us Landon, who has participated in the International Science and Engineering Fair in 2022 as well as 2023 with his cybersecurity projects for identifying malware and detecting vulnerabilities. He is currently a sophomore studying computer science and physics at the University of Wisconsin-Madison. Thank you so much for joining us, Landon, and we are very excited to have you here.
No, thank you. Happy to be here.
So, Landon, could you tell us how did you like what encouraged you to get into cybersecurity on the first place?
So, getting into cybersecurity was a bit of a journey since I had been doing programming stuff and just generally having fun with computers for a long time. And so most of the time I was spent just doing programming and making silly games and whatnot. But I started like learning about cybersecurity just online, seeing interesting talks, and there's a lot of really good resources that you can find. There's if you look up like Portswigger, that was like the first like major like resource I saw where they were talking about all these different attacks, and it was just I just was like, this is really cool. And having like a background in programming was, helpful for that because you're sort of you have to understand programs to figure out how on the one hand, you have to understand programs to figure out how to break them. But on the other hand, there's also sort of you have to change your perspective a lot because when you're as a programmer, you're thinking of, the ways things are supposed to work. And in cybersecurity, you're thinking about the way they're not supposed to work and all kinds of, unintended behavior. So it's sort of both a blessing and a curse having come from just programming.
That's a very good start. But cybersecurity, or in other terms, it is also called hacking, and it has a very negative connotation to it. So, how do you like? It is used for good, but can you explain to others, or like, have you seen any personal story of how cybersecurity was, or how hacking was used for good, or have you seen anyone else use it for good? Because it is a very thing associated negatively.
Yeah, so there's the most common way that it's used for good, which is very used to be sort of rare and is now, a huge, huge thing, is like penetration testing. So what happens is you have, some software and you just tell people to go look and try to hack it, try to find bugs and whatnot. And you don't do that to exploit them. You do that so that you tell them and they can go fix them. And that's probably the most common way. And I worked with like one of the second ISEF project was on sort of automated methods to search for bugs in this way. So it was writing algorithms that can look at, you can give it, here's a program and here's like a specification of like how it could hypothetically be hacked. And then you can ask it to like solve for how to trigger that condition, how to get it to be in a broken, hacked state. And that's not to do evil things with. It's so that it's you release it, and then every time, company X makes a new version of software, whatever, they can go use that to go see any problems with it. And so that's the biggest motive.
Okay, so that's your biggest motivation. And what do you believe is your biggest concern in the field of cybersecurity? Because again, as you told that big companies, big governments, like, everyone is using it to break stuff as well as to protect stuff. So, what are your biggest concerns in cybersecurity?
I think the biggest concerns that I have is that we have a lot of really clever people and a lot of we need more, but we have a lot of clever people and people are building really cool tools. And if you think about it, like one of the things that you'll notice as you sort of enter cybersecurity is that everyone is incredibly willing to like automate away their own work. So everyone is working on, tools and like scanners and techniques to make things faster because there's just so much volume of stuff to look at. And so I think the biggest worries are not, the big programs that everyone uses every day. It's that those programs rely on tiny little things that no one's ever really looked at, which can be huge problems. If you know about the like messaging apps, it turns out have been relying on like they're cryptography is in theory, the cryptography is fine, but certain messaging apps were relying on this like tiny little unmaintained, like just like experiment that someone had made like 10 years ago. And so the problem is not like, and this is something that like the tools that I make would totally flop on for the most part as well, because you're like looking at their stuff, it's fine, but you don't realize it's entirely reliant on some random tiny thing that no one's ever looked at. So that's I think the biggest concern is these little things that people just never really batted an eye or took a look at.
Yeah, it is actually a big concern, and I believe there's even a popular meme regarding it. How our entire world today is, based on some unmaintained libraries of the early 2000s.
Yep.
Okay, so yeah, so now coming again to your journey in computer science and cybersecurity, what were the barriers which you faced while coming into cybersecurity? Because it is a field that requires a lot of knowledge, a lot of experience, and a lot of practice. How were you able to do it, and what were like the main challenges or obstacles in your way?
So probably the biggest obstacle was that it can be very hard to sort of when you don't know how much you don't know. And so in the beginning, you sort of get used to seeing stuff. And often in cybersecurity, you might like pick like this is good. Like it's a good thing to do is to like pick a particular attack or something. Like just, then you go out and you find something and you get really into it and you're super excited about it. But the hardest part is not, recognizing that you're still you don't totally know what you're doing and making sure you can sort of like look at the bigger picture because a huge part of like the time that you do a huge part of cybersecurity is getting very, very detail oriented, right? It's like this little tiny mistake that you then figure out, oh, this can bubble up into something much bigger. But it's very important not to get too lost in those tiny mistakes and figure out like what they actually mean. So in the beginning, that was like the biggest thing is like I was like, oh, I found a vulnerability in, like this random like Google product or whatever. And I didn't. I just wasn't, I didn't, there was like the little weird, the strange behavior that I saw was there. It was, strange behavior, but it wasn't something that could actually become like any kind of a problem. So I think that's sort of the difficulty of it is you have to balance both like big picture context and like very little minute details. Like, this on the one hand, it's like this one line of code is the problem because of this like one weird behavior. But then on the other hand, it's like, okay, you have to understand the whole context of like what this application does, what it's for, how it could actually be broken in order to understand like whether that actually means anything or not.
Awesome. So keeping the big picture in the mind while not getting too lost in the details is very critical, and I think that's absolutely correct. Not just for cybersecurity, but for everything that you need to focus on the big picture first. Even in programming, when you have 500 lines of code or 1,000 lines of code, and then you need to focus on what product are you trying to build. But that is a big picture and a personal story. But do you believe there are some challenges in cybersecurity domain as a whole, which people face while they are in it, and some things which the cybersecurity domain or the industry needs to take those obstacles down and make it easier for others to come in cybersecurity?
I see. So yes, there definitely are. I think there's certain dimensions which cybersecurity is uniquely like good. Like you can just go look up things. There's lots of, publicly available nice resources. They're not always easy to find if you're a beginner, but if you hear about them from someone or find them, that part's that part's pretty good. The biggest difficulty, I think, is like getting people in there in the first place because it's this weird sort of, there's still a weird thing about like, doing hacking and stuff. Like you were talking about earlier, the sort of negative connotation. And it's almost like people treat it like a dark magic or something, right? Like it's very um like there's this like cool factor where it's like, you're a cool hacker doing crazy stuff. And there's this sort of aura of like mystery, which is very fun once you do something because you're like, I'm a cool hacker. I figured out this crazy secret way. But we kind of have to drop that because from the beginning, like in the beginning stages, from the outside, right? It's not like, oh, look at me, I'm a, cool hacker doing cool stuff. It's like there's this weird, mysterious world that it becomes very opaque. And so I think the field has had a problem with this sort of image, not just being not just a negative connotation, but being very opaque from the outside.
Along with that, is there something in particular, like, say that learning resources, or that it's like, yesterday we were discussing regarding robotics, and a thing which comes in robotics is that it's pretty expensive because of all the
Oh
hardware.
yeah.
So, is there any similar thing in cybersecurity which you believe? Not just like connotation or being opaque. But I realize that opaque is actually a very good point because I never thought of that. But is there anything additionally, like which which hinders others to get into cybersecurity?
Yeah, so I think honestly, you have to like you were saying, like I totally agree. Like one of the big problems with like engineering type stuff and robotics is it's expensive. You have to, get all this, you need all this physical, you have to buy physical things. And like cybersecurity and programming, you don't need that as much. But there's sort of an analog to that, which I would say is like sort of your like networking type things, right? Getting to know other people. There are like resources online and there is stuff, but it can be very, very weird and hard to navigate without not like expensive equipment or anything. It's just, a laptop, but without like a group of other people who is like going through things with you. Sometimes that means like, people who are more experienced than you can help guide you, but sometimes it's more helpful to have like people who are at your level you can learn, with. And I think because cybersecurity is still sort of this niche, that's probably the closest analog I can think of because like you can build, a robot or whatever with trash you find around the house. It's just a lot harder and a lot more limited. And something very similar happens when you're trying to just, strike out on your own in the cybersecurity world.
So I think I can phrase that as access to a community is a hurdle to get into cybersecurity. Now we also have some interesting questions in the chat section. One
Yeah,
is by
please, let's hear it.
Sharon. Yeah, would you like to take them up?
Yeah. So Sharon asks, with AI coming up and the availability of data on the internet, would that impact cybersecurity in the foreseeable future? So it's interesting. AI tools that we have right now aren't at the level of like, you know, you can't ask ChatGPT to go hack anything. They there is a lot of really interesting stuff that I've seen on training like large models on like specific code bases, and then you can sort of ask it questions about that code bases. And most of the stuff was supposed to be for programmers. They can be like, oh, where's this function I wrote, a month ago, and you could just ask it. But that could be also very useful for someone like the other side, a red team or some kind of cybersecurity person going looking, you know, because one of the things you have in cybersecurity is you have sort of some potential guess, like, okay, maybe, I could, get this function to return like the wrong type, and then that would break everything. And so now you have to go like look through everywhere. Where is that function called? Like, how could I get to that point? And then how could I get to those points that get there? And so it's sort of this like iterative process. And I could see AI like coming to speed that up and being like an assistant. I like that idea. And I think there's a lot of cool stuff you could do repurposing like the code, the tools that were built for programmers. And then if that hopefully answers your question on my thoughts.
Yeah, sure. There's another question by Tamanna. She asked, since human mistakes are a big reason behind cybersecurity issues, what are some simple steps organizations can take to, make their security much better and yeah,
Yeah, so it's
to
true.
help
There
people
are
stay alert?
Yeah. So it's a lot of little tiny mistakes. I think probably the biggest thing is like you'll see these things and it'll be something that if someone had just like looked at it, they would be like, okay, that's not a good idea. It was a lot of security issues result from, code that was just kind of clearly like rushed out. And so one of the best things that you could do is to just make sure everything's reviewed. Have someone like having developers who know at least like a little bit about security can be very helpful. And so that's one of the things to do is to bring like cybersecurity knowledge into the development teams. Even like it was because again, I started like from a more programming background, and as soon as even with just a little bit of like just trying to think like a hacker every so often. It's you can sort of look at your own code and be like, oh, I should not do that. And that's definitely those are sort of two helpful things because we do make mistakes. We make mistakes all the time. But like we have the capacity to get over them, right? We can build, rockets and like life sensitive, equipment that we trust people's lives to. And, you take elevators all the time. And if an elevator breaks, it would be it could be, very, very bad. But we put, basic guardrails on the outside to, you have one of the fun things is, elevators have like the safety brakes so that if it falls, it'll catch it in free fall. But even if that fails, there's a giant spring in the bottom of the elevator, which it'll crash onto so that like no one you probably make it, injured, but just handling the worst case scenario. And so you have both like careful design on the inside so that that doesn't happen and this you don't have to worry about that and just like safety mechanisms on the outside like we can if if you like elevator designer people are obviously thinking a lot about safety and we can do a similar thing with code if the people writing the code are thinking about security it can go a long way.
Definitely adding, firstly thinking from a point of view as a hacker, reviewing your code yourself, and after that having guardrails and security measures as backup
Mhm.
systems if in case anything fails. Definitely that helps. Adding to it, would you like to add any other factors while building any cybersecurity project, which one should have in consideration?
Like factors that would help a project become more secure.
More secure, or like in general while anyone is building a particular project in cybersecurity or even programming in general, what factors should he or she or they have in mind while building it?
Okay. So I think the thing that helps me the most with this, and this is just by advice, you could ask someone else, they'll probably tell you something different. But is to sort of think about the flow of information, right? You have some sources, which are like places where, people can put information and whatnot, and you have some sinks where that information is used for whatever. And, the hacker's game is to put something in, you know, put something in the source that causes, weird or bad behavior in some kind of sink. And so you want to be on that's the most important factor that like I think of is being able to be like, okay, this is a source of information. I'm going to make sure I only what is needed, is allowed to flow here. You don't want to be like crazy restrictive, but just be like, don't let anything totally crazy fly, assume that your source can do whatever. And then on the sinks, like if you see, something that looks sketchy, don't just be like, okay, well, I'm only ever going to pass like the letter A to it because like think about it. Like, am I actually only going to ever pass the letter A to it? What happens when I come back to this code in a month and redo it? Am I still going to be, sure of those assumptions? So the most important factor I'd say is like just being able to sort of trace the flow of information because then you can see, okay, here's, all you need is a exploitable sink and an accessible source.
Awesome. So that was actually a very good you know analogy, or maybe a principle which one should keep in mind, that never let like be mindful of both the source and the sink and ensure everything is secure from both the sides. Now coming back to our topic of cybersecurity, what advancements do you look ahead in your journey, or are excited, or the advancements which you are very excited of in cybersecurity?
Yeah, so there's a lot of interesting stuff. Personally, I've done a lot of stuff with like automated methods. So not me finding vulnerabilities or me finding, identifying malware families, but like writing tools that can do that. And there's a lot of really interesting stuff there. And people have been both like pushing security and more and more things because it's like, what about like the hardware that runs on your CPU? Could there be a vulnerability in the physical hardware on your processor? There can be. It's very bad. Um, but this is there's new areas which people are talking about, and many of these are so like complex, and a processor is billions and billions of transistors. You're operating at such a large scale that you sort of have to have tools. And so that's, I think, a really cool shift to think about, is going from like as much fun as it is to be like, here's, a specific function I found which is garbage, and here's how I can cause it to blow up. Moving to the more abstract sense of like defining ways things can go wrong. I'm thinking about that in a way that applies to a huge range of systems, even ones that are like hardware and software. A lot of the same principles apply. One of the There is a type of very common bug called a use after free, which is when you have some location in memory, you free it, you say, I don't need it anymore, so it just gets filled with whatever. But then later you actually use it, and so you end up pulling down, some random junk that could have been someone else's password if you're lucky. And, researchers studying processors have found like modern processors are so complicated that they store information in their own little memories and have their own little groups. And they found a use after free, like in hardware in a processor, which no one would have like thought before. So that's where like the sort of direction of advancement that I get super excited about is this kind of like the way people apply these like abstract concepts and can find them in all kinds of like totally disparate places.
Awesome. And that was your personal enthusiasm, like use after memory, or in particular automating how to detect malwares and their malware families. Do you see a general trend in the industry of cybersecurity, like with AI, or even in malware? You personally have used graph neural networks for the
Yep.
identification of malware, so that was a very high level AI project. But where more do you see the industry going, especially in automating the finding of malware, and industry in general with web, OSINT, and Stegno, and etc.?
Yeah, so I think like I might have said this in the beginning, but if you it's like a little bit jarring from like an outside perspective to go see cybersecurity as this industry that is so desperate to automate away all of their jobs, because there's the volume of what we're trying to analyze and understand is just huge. And as again, I'm coming back full circle because why not? But in the beginning, he talked about how like these big projects can rely on a huge array of tiny little libraries 10 years ago that no one's looked at, right? So the only way to really handle this sort of massive scope that security now lives in is with automation. And so I can only see it sort of growing and getting bigger. And a lot of new methods have been developed to sort of trim down the space, because even like you can't just go pass every possible input to a program and see what happens anymore. And so we're seeing a sort of progression where you're being more and less like logically strict. So in the beginning, it was like, okay, we were going to do fuzzing. So we're going to pass every possible input into a program and, see if any one of them can break things. And then we started saying, okay, well, maybe we can make cleverer, fuzzers where they'll try to learn like which parts of the code we're repeating work. And it's like less strictly accurate, right? You're making assumptions. You're not like going by pure logic anymore. You're sort of guessing. And that worked better. And then like now as we're moving more like neural networks and stuff is totally removed from logic, right? You're expecting it to learn some level of logic itself. It's just essentially guessing, and that works even better. So there's, I think, a sort of departure from pure like logical methods, which was sort of how we did automation in the beginning, to these sort of heuristic, like this seems like probably a better idea, so let's go explore that first. Which is kind of different from what I did. Like the techniques that I studied were still grounded in logic. So I'm in the middle of this this sort of stage where it's automation, but not heuristics. And so that's the sort of direction I see things going.
Okay, so we are running out of time. So last two questions, if you can
Mhm.
answer them very, very shortly.
Yep, I'll be
First
fast.
is you yourself were a student researcher. What importance do you feel of students, student researchers in cybersecurity? And second would be, what would be your advice? Because a lot of our viewers here are students or undergraduates. So what advice do you have for them to come in cybersecurity or to, work in cybersecurity?
Yeah, so I think the best advice I would have is go to like some website, just pick some vulnerability and try to just like understand it. Because when you pick, one thing, it's not this like weird, scary thing. It's not this like vague assemblage of like weird hacking nonsense. It's like, okay, you do this, it breaks this, which causes this. And so I think that's just like start with something specific and then slowly add to your sort of tool set, your toolbox of vulnerabilities you're familiar with.
And what importance of student researchers do you see in this field?
Yeah, so
High
like
school, college, yeah, whatever.
there's a lot of again like it's just these huge scopes and these tiny things that haven't really been explored. So you can find it's very if you find something like you're not going to go do like a chemistry experiment in your first year and discover something no one has ever seen before. But in cybersecurity, you can just pick something that not everyone uses. Pick some weird thing that like you use that is kind of niche and go find some weird behavior or maybe even a vulnerability with it. So the huge scope of security gives a lot of leverage to student researchers.
Okay, thank you so much, Landon. It
Yep.
was a very exciting talk. In fact, I think we could go whole day or whole night because wherever you are from. But yeah, it was a really fun and really engaging sessions. Does anyone have any last questions if you want to pick or anything which you want to give as an advice to the students?
I don't know. The last question
Anything
was
in
kind of
general,
yeah, give
not
us
just
some advice.
cybersecurity in general.
Yeah, I think just maybe this is a little highfalutin, but just explore stuff. Like just pick something small and just try to understand it. There's a lot of it's the field itself is opaque, but the way you can kind of reach that is just to focus on something specific and go look it up and you can just again like the port swigger is I love that because it's just a list. It's just a list of bunch of vulnerability types. You can just pick one and then just go run with it.
Okay, thank you so much
No, thank
for
you.
coming and sharing your knowledge. And we hope to have you in future as well. Thank you again.
Totally. Thank you
For
so much.
others, yeah, for others, if you want, there's another meeting after this. So I would request everyone to join that meeting. Thank you once again.